Welcome to the last lesson in Chapter 13. I know, I'm excited too. And today it's all about writing scientific notation. I've got some steps here I think make it a little bit easier. Steps to writing numbers in scientific notation. Number 1, move the decimal point to the right of the first non-zero digit. Reason being, remember that in scientific notation, we need that first number to be a number that's 1 or more, but less than 10. And if you place the decimal point to the right of the first non-zero digit, apparently I cannot say that sentence, the first non-zero digit, you're going to end up with a number that fits those requirements. Step 2, count the number of places you had to move the decimal point to get it there. That determines the power of 10. So that determines what your exponent's going to be when you multiply by a power of 10. You use a positive exponent if you move the decimal to the left, which seems kind of weird, but math, there's tons of opposites going on. I'll explain why that happens in just a moment. And you're going to use a negative exponent if you move the decimal point to the right. Check your answer by putting it back into standard form. So basically in the last lesson that we did, we went from scientific notation to standard form. Now we're going backwards. We're going from standard form to scientific notation. That's why this can hopefully make sense that you'll use a positive exponent if you're going to the left because we're undoing what we did before. And when you undo, it's opposite. Again, negative exponent if you had to move it to the right. So let's try a couple of these. Here we go. I have 8,600. If I want to write that in scientific notation, I need the decimal point to go right here between the 8 and the 6. And that's what I mean by place it to the right of the first non-digit number. I said it again, the first non-zero digit. So I want my first number here to be 8.6. That's where I need my decimal point to be. I'm going to multiply that by a power of 10 in order to figure it out. If I want my decimal point here, doesn't that mean I had to move it 1, 2, 3 places to the left? It says use a positive exponent if you moved the decimal to the left. I did. I moved it 3 places to the left. So if you have to move your decimal point to the left, you're using a positive exponent. Reason being, if you take 8.6 times 10 to the third, wouldn't you have to move your decimal point 3 places to the right to get it back into standard form? And 3 places to the right would give you your 8,600 you started with. So hopefully this left positive makes sense. Okay, opposite land here. My first non-zero number, I said it right. My first non-zero digit is 2, so that means I want my decimal point to be after that 2. In order to get my decimal point there, and I'm going to write multiplied by a power of 10, in order to figure out what exponent I need, I have to figure out how many places you moved it, and we had to move it 1, 2, 3 places to the right. Use a negative exponent if you move the decimal to the right. So I move that one right 3, that means it's going to be times 10 to the negative third. And think about this, if I wanted to get from here to here, if I took 2.4 times 10 to the negative third, doesn't that mean move it 3 to the left? Which 1, 2, 3 to the left brings me back to what I started with. Alright, so basically, if I'm starting with a number that is 10 or more, I'm going to have a positive exponent. If I'm starting with something that is less than 10, I'm going to have a negative. If that doesn't make any sense, don't worry. You'll see the patterns later on. So let's go with this. I have 50,000. I want you to write that in scientific notation. So step 1, I need to figure out where I want my decimal point so that my factor is 1 or more but less than 10. And that would be right after this 5. So I want 5, and I'm going to go ahead and write 0.0. If you just wrote 5, I wouldn't mark you wrong. I'm going to multiply that by 10 to the. Now to get it here, I had to move it 1, 2, 3, 4 places to the left, which makes this a positive 4. If you want to check to make sure that you're right, just see if I took 5.0 and I multiplied by positive 4, that would mean 1, 2, 3, 4. And I'd be back to what I started with. Yay! Alright, letter B, just underneath that, I have, a really large number here. How much is that? 25,000? Is that right? Nope, it's 25 million. Alright, so I want to put this decimal point between the 2 and the 5. And I'm going to multiply that by 10 to the. You had to move it 1, 2, 3, 4, 5, 6, 7 places left. Moving it 7 places left means a positive 7 for an exponent. You want to make sure that you're right. Actually do 2.5 times 10 to the 7th, and you'll see. Yep, that's exactly what you get. Okay, go to letter C. My first non-zero number is 5, so now I want the 5.0. That's what I want to happen. If you just wrote 5, it'd be okay. I'm going to multiply that by 10 to the. To get the decimal point after the 5, you had to move it 1, 2, 3 places to the right. When you're moving it 3 places to the right, it's a negative 3 because it's opposite of what we did before. Yep. And if you wanted to check to make sure that you were right, move it back 3 places. When you multiply by 10 to the negative third, that means to go 3 to the left. You'd end up with 5 thousandths. All right. Here, my first non-zero number is 5. I'm going to write this full amount here. It's 5, and then there's a 0 and a 6. I want to include that. If all those values aren't 0 after that, please write all those numbers. I'm going to multiply that by 10 to the 1, 2, 3, 4. We had to move 4 places to the right to place a decimal where we wanted, and that movement right means negative. And if you wanted to check it out, make sure that a movement of 4 left gets you back to where you started. And it does. Okay, for letter E, I just put some words around this. I'm asking you to do the same thing. The directions said to write the value in scientific notation. Google purchased YouTube for. Do we know how to say this number? Want to think about it for a minute? So here, this would be 1,000, 10,000, 100,000, right? We said this is million, 10 million, 100 million. After 100 million, we have billion. So I have $1,650,000,000. Wow. I know. It's crazy. Can't find that in the cushions of the couch. I want you to write this amount as a number in scientific notation, or as a scientific notation expression. So I first have to figure out where I want my decimal point to go. My first non-zero number is 1. So I'm going to have 1.65. I'm going to multiply that by 10 to the. In order to get my decimal point here, you had to move 3, 6, 9 places to the left. Movement left, when you're writing numbers in scientific notation, requires a positive value. And again, to check it out, to make sure that it's not negative 9, if you took 1.65 times 10 to the 9th power, you would have to move that decimal point 1, 2, 3, 4, 5, 6, 7, 8, 9 places to the right to get back where you started. So we know that that exponent is correct. Okay, the 2004 Indonesian earthquake slowed the rotation of Earth, making the length of the day not a lot shorter, a teeny tiny little bit shorter. So I want this value here to be written in scientific notation. Step 1, place your decimal point to the right of the first non-zero digit, which is 2. So I'm going to have 2.68, or 2 68 hundredths, times 10 to the. To get it here, you have to go 1, 2, 3, 4, 5, 6 places to the right, which makes that a negative 6. And again, if you want to check it, look at it this way. If you took 2.68 times 10 to the negative 6, wouldn't you have to move 6 places to the left? And right here, you'd have to go 1, 2, 3, 4, 5, 6 places to the left. So we know that we are good. All right, turn your page. I know, you probably thought it was over. Almost. One more little thing, and then we will conclude chapter 13. I want you to know how to multiply numbers in scientific notation as well. So, you get to use your properties again. I know, they're ingrained throughout everything. You can use your commutative and associative properties of multiplication, and you actually get to use your product power properties to multiply numbers written in scientific notation. So here's our little example here. You're going to get a problem like this. And this is basically taking a number in scientific notation. Let me zoom in a little bit. Because this is a scientific notation expression, and so is this one, right? And we're going to take that, and to start off, I'm going to use a commutative property because I know this is all multiplication. And I'm going to put the 3 and the 5 next to each other because those are easy to multiply. And the 10 to the negative 5th and the 10 to the negative 2nd power, I'm going to put those by one another. I'll show you why in just a moment. As far as the associative property goes, I'm going to group the 3 and the 5 together, and I'm going to group those expressions with the same base together. So that's my associative property. order to simplify that, 3 times 5 is 15, and you learn that when you multiply expressions with the same base, this is that product power property, you can bring over the base and add the exponents. -5 plus -2 is -7. The only problem with this one, and I'm not really going to give you a ton of them this year that do that. Next year in Algebra 1 you'll see more of them. But this technically isn't in scientific notation. The reason being, this is 15. The first factor in scientific notation is supposed to be 1 or more but less than 10, and 15 doesn't fit that requirement. It's too large. So I could rewrite 15 as 1.5 times 10 to the first power, right? If I took 1.5 times 10 to the first power, that means I would move this one place to the right and be back to my 15. And then I can go ahead and put those bases together. So 1.5 and 1 plus -7 is -6. If that's confusing, don't worry. I am quite certain we'll end up doing these ones together in class. If you're absent, a simple little 5-minute talk at lunch will probably get you caught up with that. But again, most of the problems that we do are going to end at this step. I'll make it so that this first factor comes out to a number that fits the requirements. So let's practice a couple. Enough talk. Write your answers in scientific notation. So here's here's an expression written in scientific notation multiplied by another expression written in scientific notation. And basically, because this is all multiplication, I'm allowed to pick any order that I want. So I would personally choose to multiply the 2.5 and the 2. And when you take 2.5 times 2, yes, you get 5. I'm supposed to multiply that by a power of 10 for it to be scientific notation, right? Well, it just so happens that I'm multiplying 2 powers of 10 right here. When the base is the same, bring over the base and add our exponents. 8 plus 3 is 11. So this whole expression right there is equivalent to that. Scientific notation just helps to make this a little bit less complicated. All right, let's try one more. And again, we're allowed to do this because it's all multiplication. If I had an addition sign, that's going to change things up quite a bit. Don't worry about that yet. So here, I'm going to go ahead and multiply my regular old factors, not my powers, together. And when you take 5 and you multiply it by 1.5, you get 7.5. And I want to multiply that by a power of 10. I have 10 to the 4th. 10 to the -4th times 10 to the -9th. Remember, when you're multiplying exponential expressions with the same base, you can bring over the base and add the exponents. -4 plus -9 is -13. And you're done. You're done because this right here is a number that is 1 or more but less than 10 multiplied by a power of 10. Same thing here. 5 is 1 or more but less than 10 multiplied by a power of 10. We are done with chapter 13. Woohoo! See you tomorrow so we can celebrate.